All right, this is part 1 of the Math 136 Final Exam Review A. The parts are going to be broken up into 9 problems at a time. Since there are 36 problems on the review, that means there'll be a total of 4 different parts. So let's look at part 1 and just go in order. So simplify, answer only with positive exponents. So we're looking at 3x to the negative 10th, y to the 5th, times, because there's nothing here, 5x to the 5x to the 7th, y to the 2nd. Notice there are no outside exponents on either of the parentheses, so we can go ahead and directly multiply. So 3 times 5 would be 15. X to the negative 10th times x to the 7th, we add our exponents, so that's going to be negative 10 plus 7. And then y to the 5 plus 2 for those two exponents. So this is 15x to the negative 3, y to the 7th. We're not allowed to leave our answer with negative exponents, so remember, if you have an exponent that is negative, it is in the wrong location of the fraction. Therefore, this will move to the bottom and become x to the positive third down there. So 15y to the 7th over x to the third. For number 2, we want to factor completely. If the polynomial cannot be factored, write prime. This is a trinomial because it has 3 terms, and because it does not lead with a 1, we need to use the factor by grouping method to try and factor it. So I always do the number in the front, a, times the number at the end, c. This is negative 24. That means that we're looking for 2 numbers that multiply to make negative 24, so they have to be a positive and a negative. And then they still have to add to this middle term. So when we list our factors of 24, just going through the list, it looks like 4 and 6 are going to have to be the pair, because if we had a positive 6 and a negative 4, that multiplies to negative 24 but adds to 2. So remember, we split the middle, expanding it out using those 2 terms. Make sure that they both get the x on them. And it doesn't matter which one you write first as long as they both get the x. And then we would do factor by grouping, which means we group these in pairs and we pull out the GCF for each pair. So I can pull a 3x out of the first pair, which makes this an x plus 2. If your second pair leads with a negative, you need to pull that out, and they're both divisible by 4. If we pulled out the negative, that means you're going to have a positive here in the middle. When you have a matching parentheses, you know that this is going to factor. So this is going to be x plus 2, and then the leftovers become the other binomial, 3x minus 4. And there's that one. For number 3, we're wanting to simplify the expression, and it is a rational expression that is complex rationals because it's a fraction over a fraction. Typically, what I suggest doing is to rewrite this as multiplying by the reciprocal first. So this is 3 over x minus 4 times x squared minus 16 over 4x. Because this is a pretty basic one, there's no adding or subtracting. This is usually the easiest method to solve this. You would want to factor that top. So this is 3x minus 4 times x plus 4, x minus 4 over 4x. There's an x minus 4 and an x minus 4. Since we're multiplying, one on top and one on bottom, we can cancel them out. So our final answer is 3x plus 4 over 4x. Or if you distribute it, 3x plus 12 over 4x. I usually just leave it in factored form, but either one is okay as long as your teacher's okay with that. So let's look at example 4. Okay, this is what we call the big factoring problem. Because you notice right here in the middle, there is a big plus sign that is not in a parentheses. That's kind of a big red flag to me that this has 2 big, what I call blobs. 2 big terms, and that's kind of under my line. So this is a big term all multiplied together, and this is a big term all multiplied together. So what I typically try to do first is I try to find something in common that I can pull out. So to do that, I multiply these these little monomials together. They're not going to have any exponents on them, so it's okay to multiply them together. So it's negative 6, 3x plus 1 to the 6th, 2x minus 5 to the negative 4, plus 6 times 3 is 18. And this is, I usually put these in the right order again. So 3x plus 1 to the 5th, because that came first here, and 2x minus 5 to the negative 3. Then we ask, what do each of these terms, now that they're a little cleaner, have in common? You can pull the negative out or not. It depends. Sometimes it's helpful if you pull it out. Sometimes it actually creates a negative somewhere else later. So I'm actually going to leave it this time and just see what happens. We can play with that. So I'm going to pull out a 6 because they both are divisible by 6, the numbers out front. We have at least 3x plus 1 to the 5th in common, because this one has 5 and this one has 6. With negative exponents, you have to be a little bit careful. Notice we pulled out the smaller of the two numbers when we did 5 and 6. We do the same thing here, but the smaller of the two numbers is negative 4. So 2x minus 5 to the negative 4. And we'll have a big bracket, and we'll say what is left in each part. So if I pulled out a negative 6, or excuse me, I had a negative 6 and I pulled out 6, I'm going to have a negative 1 left over, and a 3x plus 1, since I only pulled out 5 of those. I pulled out all of those negative 4. 18 divided by 6 is going to be 3. I pulled out all 5 of the 3x plus 1s, but I had negative 3 here. If you pull out negative 4, you're actually dividing, and when you divide, you subtract exponents. So negative 3 minus negative 4. That's actually negative 3 plus 4, which means we have 2x minus 5 to the first power left inside. So if you pulled out the right one here, this should still have now a positive 1 on side. So let's rewrite this. This is 6, 3x plus 1 to the 5th, 2x minus 5 to the negative 4. I'm going to start cleaning up the inside here. This will be negative 3x minus 1 plus 6x minus 15. We'll want to add those like terms inside that last parentheses. So 6 parentheses 3x plus 1 to the 5th, 2x minus 5 to the negative 4. 6x and negative 3x is 3x. Negative 15 minus 1 more is negative 16. The only thing we typically don't like, remember, is a negative exponent. So we're going to move that term in that part to the bottom. So this is 6, 3x plus 1 to the 5th times 3x minus 16 all over 2x minus 5 to the now positive 4. And there we go. That's completely simplified down. Okay, let's look at number 5. This is solving an equation that has rational expression terms in it. So typically what we like to do here is we like to clear out the fractions. To do that, you have to find a least common denominator. So I'm going to factor this first denominator because it's perfect squares with a minus sign. And it looks like my LCD is going to be an x plus 3, x minus 3. Now, I go ahead and write that means my domain restrictions are that I cannot have negative 3 or 3 as the answer at the end, because that would plug back into the original and make us divide by 0. So once you've determined what everything is, you're going to multiply each term by the x plus 3, x minus 3. So x plus 3, x minus 3, x plus 3, x minus 3. As long as we do that all the way across the equation, it's legal. In the first group, the x plus 3, x minus 3's cancel completely, so this denominator is gone, and that would just be 4x minus 5. In the second group, the x plus 3's cancel, but we'll still have a 2 and an x minus 3. Be careful right here. In the middle there's a minus sign. The x minus 3's are going to cancel, and this will be a 7 times an x plus 3. So then we would want to distribute, combine like terms, and solve. So 4x minus 5 equals 2x minus 6 minus 7x minus 21. We would add our like terms on the right side, so that's going to be negative 5x minus 27. Add the 5x over, that's going to be 9x. Add the 5 to the negative 27, that's going to be negative 22, and divide by 9. As long as your answer is not negative 3 or positive 3 and you haven't made any arithmetic errors, this should be the correct solution to the equation. Number 6 is a word problem. It's a work rate problem. This is where two people are working at different paces, but they're working constantly at their rate. So it takes a girl 55 minutes to deliver the papers on her route. If her brother helps, it takes only 20 minutes. So helping means that they're working together on that situation. How long would it take her brother to do it by himself? If necessary, round to 1 decimal place. Okay, so the problem with this is that you have a girl who's working you have a boy who could be working by himself, and then you have a combo where they're working together. Since they're working at different rates, we want to know how much of the job did they complete in a single measure of time. So the way I think about this is if it takes her 55 minutes to deliver her papers on her route and she's working consistently that whole time, then it takes her on every minute, she does 1/55 of the job per minute. Okay? Working together, it only took them 20 minutes. So together, they completed 1/20 of the job per minute. We don't know how long it would take the boy to do it by himself, so we're going to call that 1 over an unknown time, which we're going to call x. Once you have your three fractions, this is how it works. It's the solo job plus the other solo job, so girl plus boy, equals the combo. The only time this is not a plus is if the two people are doing opposing jobs, like if the girl was delivering the papers and her mean little brother was coming behind her and taking them away. But since they're both doing the same job, it's an addition to make the combo. So this is, we're going to try to clear out the fractions. So we would need a common denominator of some kind. So let's think. So 55 times 2 is 110, but 20 does not divide into that. 55 times 4 is 220, and that is something that 20 goes into. So we're going to say that our LCD here is 220x. So I'm going to multiply each term by 220x. And you do need the x because of the x denominator right there. Okay, so 55 goes into 220. That was 4 times, so this will be 4x. The x's will cancel here, so that'll just be plus 220, not 222. And then, as I showed on my calculator, 20 divides into that 11 times. So this will be 11x. We would subtract over the 4, so this will be 7x, divide by 7, and that will give us our decimal approximation about how much time in minutes it takes the boy to do the job by himself. And it looks like it's 31.4. Okay, let's look at number 7. Number 7 is also a word problem, but this one is about people attending a motion picture. So we have 700 people attended the premiere of a motion picture, so total people 700. Adults have a ticket cost of $9 per person. Children have a ticket cost of $4 per person, and their receipts totaled $3,400. Okay, so what happens is we need to write adults and children in terms of a variable because we don't know how many of each we have. And since we're looking for how many children attended, I'm going to let X be the number of children. That means that since 700 people attended the event, 700 minus all of the kids should be the number of adults because we don't have any other types of people. It's adults and children. So if we've got X for children and 700 minus X for adults, we should be able to write a money equation dealing with the ticket prices. So it's $4 for every child, so that's times X, plus $9 times every adult, which is 700 minus X, equals the total tickets that they sold, number-wise, money-wise. So then we would distribute this. That's going to be 6,300 minus 9x equals 3,400. Combine like terms, and then we'll want to subtract that 6,300 over, and it's going to be negative, but so is my x, so that's going to be okay. It's negative 2,900, and we would divide by negative 5. And this, since we let x be children, we will be done because they only specifically asked about the children. So 580. Children. If we wanted to know the number of adults that were attending, we would just do 700 minus the 580. Okay, number 8 says solve using the quadratic formula. and then give an exact answer. That means do not turn your answer into to decimal answers. Do not calculate it that way. Now, the problem with this is the quadratic formula, if you remember, is x equals negative b plus or minus square root b squared minus 4ac all over 2a, where this is a, b, and c. This is already a fraction, and so are some of these. I do not want to plug fractions into fractions. Since this is an equation, though, if you know your LCD, you can clear out the fractions, and 2 and 5 both go into 10. So I'm going to multiply each term, every single term on each side, by 10. So this would be 10 divided by 2 is 5x squared. 10 divided by 5 is 2. Then we have to times it by the 3 up top, so that would be 6x. And then negative 3 times 10 is negative 30, equals 10 times 0 is 0. So this makes this a little easier to plug into because now we are using just integers for our a, b, and c. So this would be x equals 6 is b, so negative 6 plus or minus 6 squared minus 4 times a, which is 5, times c, which is negative 30, all over, so this goes completely across the whole thing, 2 times a. Okay, so let's work this out. You usually do order of operations, so we're going to start inside. 6 times 6 is 36. This would be negative 20 times negative 30, which is going to be a positive since they're both negatives, so that's 600 all over 10, because 2 times 5. So the question is, I'm going to add that 36 to that. 636 may have something that pulls out as a perfect square, so we're going to check that. So 636, is it divisible by 4? Because 4 is a perfect square. Yes. 159, let's see, is that divisible by 3? Yes. Is 53 divisible by 3? No. I could break this down using primes, so let's look at that. But I think the only thing that goes into it is a 4. But 636 is 4 times 159. 159 is 5 times 53. I just discovered that. And 53, I don't believe anything goes into that. I believe it's prime. So the only perfect square there is the 4. So this would be negative 6 plus or minus. The square root of 4 is 2. That would be a leftover 159 all over 10. Now notice that all of your outside numbers are divisible by 2. So we would reduce each of those. You don't reduce the radical part anymore. This would be negative 3 plus or minus the square root of 159 all over 5. So there's where my x equals. And that's 2 different solutions. But that's written as an exact answer. All right, so the last one for part 1 is number 9. We have an imaginary complex number situation where we have an I in the denominator, which is not allowed for us. So the way we get rid of this is if it's a binomial, you multiply top and bottom by the conjugate. The conjugate is the exact same 2 numbers, but you change the sign in the middle. The reason that works is because that gives us 2 perfect square differences to FOIL out, and the middle terms will cancel out. And everything left will be a perfect square, which will make the I go away. So on top you distribute, so 7 times 2 is 14. 7 times negative 4 would be negative 28i. Negative 3i times 2 would be negative 6i. Negative 3i times negative 4i is positive 12i squared. And yes, we do have to take care of that I squared in just a minute. On the bottom, this is going to be 4 minus 8i plus 8i, which is going to cancel, and then negative 16i squared. Anytime we have an I squared, it changes to a negative 1, which means this just changes to a regular number but a different sign because it gets multiplied by that negative 1. So on top, I have 14 minus 12, which is 2. Negative 28i minus 6i is negative 34i. On the bottom, these 2 middle terms cancel, and this is just 4 plus 16, which is 20. We need to write our answer in a plus bi format, which means we split it and reduce. So 2 over 20 minus 34 over 20i. And if we reduce those fractions, that's 1/10 minus 17 over 10i. And that would be our answer. So that's the end of the part 1 video.